Hi, first of all, my name is Carsten Tellmann, and basically he has told you everything I wanted to tell you, but okay, I repeat it in English. I work for GData, that's an antivirus company located here in Bochum, and yeah, we support this course, and we like it to have really good speakers here. And in addition to the course, we offer a small evening event with some food and drinks, and yeah, I think quite a cozy atmosphere. And if you want to get in touch with the speaker, talk about some of the details of his talk in detail, or yeah, basically if you want to get in touch with people from the organizing committee, or just if you are interested in talking to some of the guys working in the field of the antivirus companies, and basically the technical people will be there. So all of you are invited. Details to the location are also available through the course website. And if you have any questions, don't hesitate to come to me after the talk and I can explain it.
You should maybe mention the street name.
Yeah, the name is Königsallee 178. But if you can't remember it right now, just come to me after the talk and I can repeat everything. So, I guess...
Yeah, thank you very much. Yeah, the speaker of today is Gerkis. He's a security researcher in the web browser security field, and yeah, I do not want to make it so long. Feel free to start.
Okay, hello everyone. Glad to see you here at Hackpra. And today we will talk about dynamic PHP web application analysis. But before we start, I would like to quickly introduce myself. So yeah, I'm an independent security researcher working in the browser fields. I'm bug hunter. Previously, I was working in the web application security and doing some analysis and penetration testing. Also wrote some articles in a Russian magazine. Yeah, and found dozens of security issues in different browsers. Okay, so this is an outline for talk today. First of all, I will slightly introduce you into the dynamic analysis. We will recall what it actually was. Then I will discuss tools that you can use today. So then we will move to the PHP extension. I will touch a little bit of PHP internals. And finally, I will show you my own extension. Okay, dynamic analysis. Well, dynamic analysis actually exists not only in software, it exists also in civil engineering. And for example, if you want to build a safe construction, safe house, then you have to actually inspect all the materials. You actually have to test, for example, concrete. You take a concrete, some cube, and you inspect its properties. So you just get physical data, you just crash this concrete cube, you squeeze it, you test it with chemicals and other things. The same thing happens also with software. So you basically prepare an environment, you just set up like PHP environment, configure your tools, you run application runs, you collect runtime data, and then you analyze those data. Sure, you can do also analysis during the runtime. Nothing prevents you. Well, why actually you would use dynamic analysis? In most cases, it's used for profiling, for code coverage, and for tracing. Why to use dynamic analysis? What it's good for? It's good for that it operates with real data. It's quite obvious. You know which function gets which arguments, which data it has, which functions were already executed, how much time it takes to execute this function, and much else. So it also allows to avoid some backdraws that static analysis has. It doesn't have any false positives because it operates with what it has. It operates with real data. So it doesn't have any assumptions. But it's efficient and it's real wise to combine dynamic and static analysis. But combining these technologies, these techniques is actually a separate talk. It's really deep topic. So another thing, Dynamic analysis helps you to analyze obfuscated code. So you won't do this manually. It's in most cases it's really hard to do this with your hands, so to say. So some drawbacks. Dynamic analysis is not a silver bullet, and sure, there exists some things like inability to cover all code paths. You can generate really a lot of good test cases. You can generate really a lot of them, and you can run your tool 24 hours a day, 7 days in a week, but still it cannot cover all code paths because there are some conditions that should be logically satisfied, and doing so manually, automatically is really hard. It's quite impossible. Depending on implementation of your dynamic analysis tool, your tool can be slow. It depends on your implementation, in what this tool is written on. It depends on computer powers and other stuff. It can be binded as well to the platform, like Mac or Linux or Windows. It can be binded to one of the versions of PHP, because PHP actually vary, and they have big differences. So the last thing, probably not such a big issue, but still, if you execute unknown code, it may be malicious code that does some dangerous actions. For example, web shell. You analyze web shell, and if it doesn't hook any dangerous functions, it can start wiping your data. If we divide tools into their implementations, generally there are 3 types. First is a code instrumentation, which consists of 3 further types. It's a source code instrumentation. You just basically add your own instructions around the data or around the functions, or you replace functions. Then there is a compile time instrumentation. This is actually how address sanitizer tool from Google works, if you have heard. It's a really nice tool, and it doesn't have such a big overhead. And execution runtime. This is how tools like Dynamario or PinTools works. They actually patch the binary, and well, it's slow technique. Patches and extensions. Quite obvious. You use patches and extensions to extend functionality, to add additional features, and external tools, system tools that doesn't depend on PHP. They just run separately. In PHP, we have We have a source code instrumentation, patches and extensions for PHP interpreter, and external tools. In next slides, I will discuss more deeply about these tools. So, which tools actually you can use today for your dynamic analysis? Code instrumentation. These tools, actually, not all of them does pure code instrumentation, because it may be not sufficient, but let's take a look. So PHP Vulnerability Hunter. This tool is for Windows. It has a nice GUI. It's actually fuzzer. It instruments source code, then it statically analyzes it, then dynamically, and it provides you output of potential and security issues. But looks like this tool is not in development anymore. So Saner and Wafa, 2 academical works, and as usually, there doesn't exist any public tool, but the papers are still worth reading them. So Saner actually implements static and dynamic analysis together. Yeah, and Wafa does only static dynamic analysis with the code instrumentation. Can't say much about these tools because source code is not available. PHP Aspis. So this tool is actually written on C. It parses PHP, and you actually have to add PHP Aspis library to analyze your web application. But as I have read from the GitHub, this tool is really unstable. So just use at your own risk. PHP interpreters. First one is taint support for PHP. It's actually a pioneer. It was the first idea to do tainting, to do some dynamic analysis. It was proposed by Vietsavenema in 6 years ago. Real nice idea. This is what actually Perl tainting mod does or Ruby does. But the tool was discontinued for unknown reasons. But as you will see further, there exists a better tool that does the same job. CoreGrasp, another PHP interpreter developed by Core Labs group. And well, yeah, it's another PHP version. But also the project is not in development anymore. It supports, I think, 5.2. And this, the last PHP prevent is also academical work, also no tool available. Well, nothing much to say. It's important to say that in PHP interpreter projects, they actually they mention overhead because it's important. When you do your own PHP interpreter version, it's important that it runs fast. So for taint support, it was something like 1%. It's really fast. For CoreGrasp, overhead for memory usage was something like 30%. Well, I would say that it's also not that bad. For PHP prevent, 10%. And PHP extensions actually is my favorite section because I think it's the most cleanest way to do dynamic analysis in PHP. So the ByteKit, a really great tool written by Stefan Esser. He doesn't support it anymore, but still it's worth looking at it because it's actually a framework. You can use functions from this tool. It provides API. You can develop your own tools upon this tool. You can find on GitHub ByteKit, and there are presentations somewhere in internet. You can find how to use this tool. So next is EvalHook, a really small and tiny tool. What it does, it actually was supposed to show you in console what the next is going to be evaluated. So it actually catches evals, pre-replace with E, and many other things. Tool is quite small and it's not developed, but I think it should work also on the latest version of PHP. Yeah. Taint. This tool is actually an extension that does tainting of data. So it's currently very actively developed, and it's a nice tool worth probing it. As I said, it's replacement for PHP tainting support. Well, yeah. So, and dtrace, it's a 7 years old tool, but still the idea was to provide possibility to run dtrace on PHP interpreter. Well, external tools. Sure, you can use strace, truss, ktrace. Why not? It can be also useful to see which system calls were executed. Also dtrace, systemtab, ltTng, and other type of tools. And GDB, why not debugger? So if you want to use GDB, in the PHP source code folder there is actually GDB init file. It provides capabilities of showing different PHP structures like zvals and other things. It's very useful. And this is a GDB session example. Oh yeah, it doesn't see anything. But okay, I will explain anyway. So here I have set breakpoint on PHP trim. Why PHP trim? If you want to set breakpoint on a trim function in PHP, you won't be able to do that. PHP uses really a lot of macros. And there is such macro like PHP function in PHP. Well, it accepts as a parameter PHP function name, and then it chooses which function to execute next. So PHP function macro will call PHP do trim, and then finally only it will call PHP trim. Okay, on the slides will be shared, I think, and you will see details. There exists also other tools like Xdebug with different front-end tools like KeyCatchGreen, PHP Unit, and many others. IDEas and so else. PFFF, it's actually a tool from Facebook, shared on GitHub, proposed to have a static and dynamic analysis tools for PHP and many other languages, but unfortunately haven't seen it, probably in future. So why to choose PHP extension? Actually, it's transparent to application. You don't have to instrument your application. You don't add any other code, and so you don't influence any execution path. So you have also full control on the application. Well, imagine you inject your code in PHP. You're actually inside of PHP, and you can do everything you can imagine. You can dump values of variables. You can trace functions. You can get return values, you can do stepping, like in debugger, you can taint variables, and what else? Well, if you want to develop PHP extension, you might stumble upon problem like actual documentation. So there exists some blog posts, but they're really introductory. They only explain something like hello world extensions. There exists also some couple of chapters, really old. One newest is 2 years ago, but it's worth reading it. It's one of the newest. And book that's written 6 years ago, so not that much documentation. If you're going to develop PHP extension, it may be really the issue for you to find changes between PHP versions, because from 4 to 5, from 5 to 5.2, from 5.2 to 5.4, there have been really a lot of different changes. But still, where to get the information? There are many good extensions like Sukhashin, ByteKit, and Xdebug. You can take a look there. Also, there is a PHP source code and online search powered by OpenGrok, a really useful thing. Well, yes. So, what's actually PHP extension capable of? What it can do? First of all, I have to show you and tell you about PHP internals a little bit. It's just a tiny chunk, because all the topic about PHP internals is really huge thing. Imagine if one writes a book about that, what can tell one slide, but still, I will try. So this is a life cycle of PHP extension. Each of extension starts with a minute. It stands for module initialization, so it initializes variables, allocates resources, and do some vital stuff like for many extensions, like hooking functions that are responsible for executing internal PHP functions and PHP user functions. As well, at this stage, at a minute, you can hook functions that are responsible for calling eval things. You will see later on the next slide about this. So next step after a minute is init. So resources initialization. Init happens on every request you have done. So what you do inside of init actually depends on PHP extension, what you have thought about. So it's just up to you to decide what to do inside of init. You also may skip initiating a minute or init. So it's not really important to define them if you don't want to do stuff they can actually may do. So after every init happens script execution that consists in following blocks. So it's a lexical analysis, syntax analysis, then there happens a second stage of this group. It's a opcode generation, and then opcode execution on the virtual machine. So basically, opcodes are the smallest execution unit inside of PHP. Opcodes actually are like assembly for PHP. It consists also of call, jumps, and other stuff. After that happens R shutdown and M shutdown. Well, they actually do opposed stuff to everything. They just free resources. They stop execution. So, for example, on air shutdown, when a script terminates, be it die or exit or normal script termination, they would destroy a symbol table that are responsible for function variable handling, and then it does garbage collection. And the last stage is M shutdown. It frees persistent memory and well, destroys hash tables and other stuff. Actually, this block and how it looks, it depends on PHP implementation. Say if it is a PHP CGI not threaded, then it would execute on the every request starting from minute to M shutdown. If this is threaded, then it will execute minute once, and then it run every init from every init to air shutdown on every request separately. So for mod PHP, it will also happen separately. So if this is threaded mod PHP, then every init and air shutdown will execute in different processes. And if it's just a single thread, then everything will happen sequentially. There is also such thing like a persistent memory. So Zend has actually two additional groups to original C library functions. So malloc, and there is these groups actually provide the same functions prefixed with E for the functions that should work between air init and air shutdown. So this will be emalloc, ecalloc, and other things. They should be used between requests. Such functions, such allocations that should be used through the all runtime. So through the minit to M shutdown, they should be prefixed with a PE, so P, emalloc, and others. It was made generally to handle such situations that abnormal script termination, like die or exit. So this is how actually Zend fights with the memory leaks. Okay, so handling function entry and exit. This is important if you want to trace execution paths, and well, you just would understand how application executes. If you have logged every function execution, you know its execution time and other stuff. So as well, you can intercept data. So it's really interesting to watch what has been passed to the functions, what is not sanitized, not filtered, and other stuff. These functions are responsible to handling function entry and exit. So the first one, foobar execute internal, is the function that would hook, so to say, internal PHP functions. Foobar stands just for arbitrary PHP extension, and what it can do actually, it can well, it can dump opcodes, it can dump variables, handle function entries, just what are for internal PHP functions. And the second one is basically the same, just for PHP user functions. Is a foobar execute, does the same stuff that previous one. It's important to know that actually execute internal wouldn't catch callbacks. That's one of the drawbacks of PHP, what you can do. So if one internal function calls another internal function, you won't see that. Quite obvious thing that you want to do in PHP, implement your own functions and classes. Well, in huge projects, there are sometimes conditions that you want to move some part of PHP to the C, and in such a way to fight with bottlenecks to optimize execution time, or you want to utilize some operating system specific functionality that would look in PHP ugly or like a hack. Well, also you can implement your own debugger. So opcodes, as I said, opcode is something resembling like assembly, and it's the smallest execution unit inside of PHP. So let's say you can dump opcodes, and what it allows you to do, you can actually see how PHP executes on the most low level. So it actually allows to analyze obfuscated code. It's easier to do so when you see the code graph, visualized execution paths. This is an example from the PHP taint extension. What it does, it sets hook on the PHP Zend echo opcode, and what you can do, you can actually watch data. So for the echo is actually not a function, so you cannot hook it so easy. It's actually it's a construct. Hook, dynamically evaluated strings. So it's pretty obvious benefit. So you can hook and you can see what happens inside of eval, create function, assert, and trigger place with a modifier e. This function does this hooking. So you just get source code of that is going to be executed. Setting Zend extension callbacks. Actually, it's not really useful, but it provides the same capabilities that you could do without these callbacks. First of all, it needs to be clarified that there exists, so to say, two types of PHP extension. It's a simple PHP extension, and the second one is Zend extension. What they differ with is actually that in Zend extension you just have to specify additional structure. I will show you this structure later. So you do basically the same stuff. You set handlers in this structure, and you can handle function entry and exits, what was already mentioned. You can manipulate op-array. It's just array of opcodes that was already mentioned too. But the most interesting stuff is a statement handler that would actually allow do profiling and would allow you to implement your own stepping debugger. So on the left side, if you see, I hope you see, there is actually a structure that has to be defined in PHP extension. So I have highlighted only one important thing, statement handler, but comments are actually pretty obvious. Yeah. And on the right side is a structure from the PHP source code itself. So what you can do with PHP extension? It can be assistant in debugging like Xdebug or VLD does. You can harden and secure PHP like Sukhoshin. It's execution time optimization and caching like APC and others. Evaluating security with the already mentioned tools. Protective measures, ZenGuard, IonCube. So pretty much what you want. Now I would like to introduce my own extension. So it's called PHP Vulnerability Tracer. It's a set of tools. It consists of different modules, 5 modules that does different tasks. They would assist in security audits, so they can be switched on and off separately. And so yeah, as it's PHP extension, it's transferred to web application. It tries to be fully automated, so you just run your application and then you watch logs and you watch what has changed. You analyze data. There are also some customizable things you will see later. So basically, you have run your application, and then you can draw a call graph. So it visualizes code execution. Then quite obvious thing that you want to have is hooking strings that are going to be evaluated. So it catches also marker in your function arguments. It dumps functions or variables. It can dump one variable or all variables. That can be very slow. opcode dumping for lower level analysis. So when you have obfuscated code, you can switch on opcode dumping and see what actually happens. So this is a ini file. Problems with the PHP extension. It may be slow because we will see later why actually. This is one main drawback, that it's slow currently if you run on heavy web applications. It works only on Linux, only on 5.3. I have started development on 5.2, but well, I think it would work on both versions. Some testers have said that it would work also on FreeBSD or on Mac, but I haven't tested, so I'm not sure. And currently log files are just plain text files. Some people may not feel comfortable with that. And there are requirements like Dot and Perl. So I have run tests on WordPress to show some statistics. And I was just opening simple page like index PHP. So without PHP it would run in some 0.14 seconds. Slowest module is actually dumping opcode. Well, it's quite obvious because PHP has to stop at each opcode and then execute further. So the most fast functions modules are trace function and eval hook. Yeah, demo. So we will just take a look at how WordPress gets analyzed. So I can actually see escape. Okay. Yep. So this is an ini file. We just set path to the logs. You don't see? Those are comments that you don't see. It's not important. So, okay. This is setting for to dump p variable, and then you want to catch string woot in all the functions. Now let's restart Apache server. Yeah, I haven't run opcode dumping module because it's too slow. It's already have run previously. So it's a WordPress page. It executes, and now take a look at, there are several files. These are log files. We will explore them later. Now we're gonna run some tool written on Perl. What it does, it actually converts dot files to SVG, and it's JavaScript stuff and CSS just to make it more, to graph more beautiful and comfortable to use. So we have run it, it's okay. There have appeared additional files. So these are opcodes. Each file stands for each function. Here we see opcodes and additional data. Really resembles assembly, doesn't it? So now we will take a look at graph. So I think it's the most interesting feature. No, later. Now we will explore logs files. So these are statistics, some like function numbers and etc. This is a raw file for the function that got traced. So you basically can see every function that was executed. Main is actually a function that executes in PHP most first. It's like in C. You just don't see it from user mode. Here are information like path name, line numbers, deepness, and many other stuff. Marker, no, not marker, variable. So we have chosen to dump variable p, and we see it here. provides the same information as previously. This is a code evaluated in WordPress. Actually, it doesn't have any evaluations. I have added code in plugin explicitly, just to show that it can catch strings. So the next one is, yes, these are other markers. So we have chosen to catch wood, and we see the different additional information, like the type of the function, be it a Zend internal function or user function. We see actually the execution time, we see line numbers and many other useful stuff. And yes, it's time for to take a look at the graph. So graph consists of basic blocks, and each basic block consists of some array of functions. These functions doesn't depend on each other because it actually doesn't make sense to make dependency between them. It makes sense to make dependency between variables. So this is actually how looks WordPress. Really huge. Now we'll explore some basic block. So really tiny one. So when we click on the function name, then we got arrow highlighted with red, and then we can trace back to the parent block that called this one block. See? Let's get traced back to one more block. And if you click on the line number, then it will open a source code viewer. And then if you click on the function names, actually you can open the place where the function was defined. Actually, it looks much more beautiful on Windows and Chrome, not on Linux. I'm not a web developer. Okay, so you can actually open as many windows as you want, and it shows you path to the function. It highlights with the pink color the place or the function you have clicked on. And with the orange you can set your own mark places. Well, yes, that's it. It's actually my most favorite module in this extension. So, okay. What I want to do next is actually to optimize this PHP extension because it might execute slow, and I want to make it capable to run together with flooding. The next thing is to add variable tracing. So at this point you actually would be able to see where the function where the variable has split, where it had merged with another variables when it gets concatenated, and what happens actually to the string. So connecting logs and graph. Well, with this feature you would actually be able to show on the graph, on the visualized graph, which data has been executed. So you basically click on the variable and you see its value. I'm not sure if it's useful because there exists a separate extension, but data dating. It may be useful to combine with other features that already exist. Graphs for opcode. It may be useful to see how it exists just in basic blocks, not just in separate files. And probably logs management should be improved. and bugs. You can actually submit bugs, and I will try to fix them. I'm pretty sure there should be. So I would like to thank Stefan Esser for reviewing slides, for providing valuable comments, and as well I would like to thank Vladimir Vorontsov for discussing ideas and for testing. So references, well, yeah, these are references to this topic you can use. These are interesting to read. Yes, and any questions if you have. That's it.